Here are some more examples of factoring out the greatest common factor. So if we want to factor this one, well, if I was to just, so my normal, if I'm just looking at 7a cubed and 14a, if I'm kind of ignoring the fact that there's a negative there, I would say that my GCF, my greatest common factor, is 7a. Now, if I was to do this, I would end up with, the opposite of a squared plus 2, if I was to factor out just a 7a. And it turns out when we were doing this factoring out the greatest common factor, this is not exactly desirable. We want this leading term should be positive. So instead of factoring out a 7a, since I'm noticing the leading term of this polynomial, my starting polynomial, is negative, I'm actually going to start off by factoring out a negative 7a instead of a positive 7a. And other than that, it's the exact same process. Negative 7 divided by negative 7 is 1, so I don't need to write anything. A cubed divided by a is a squared. 14 divided by negative 7 is negative 2. A divided by a is 1. And so I end up with, well, something that's equal to the original factored form here, except the polynomial that's left over on the inside of my parentheses, the leading term is positive. This has a positive coefficient. The reason we like to do this is because we like to, basically, we don't like there being an ambiguity of which way is actually the factored form. So at some point, sometime along the way, we said that, okay, if we're going to end up with a polynomial, any polynomial we're going to end up with here, any with more than one term, then we need to have the leading coefficient being positive, the coefficient of the leading term being a positive number. If there is any negative, it needs to just be in this stuff out in front. So it's just, I don't know, I'm not exactly sure when this came to be, but that's how we do it. So looking at this one, you'll notice my leading coefficient is negative, so I know that when I'm factoring here, I need to factor a negative out with everything else. So I'm just going to write that down as part of my greatest common factor. Then I'll look at my then I'll actually start figuring out what my greatest common factor is. Between the 4 and the 8, my greatest common factor is 4. Between y squared and y, my greatest common factor is y. So I'll open up my parentheses and leave space for two terms. Negative 4 divided by negative 4 is 1. Y squared divided by y is y. So I get 1y, which I'm just going to write as y. And 8 divided by negative 4 is negative 2. Y divided by y is 1, so we end up with negative 4y times y minus 2 here. Alright, once again, my leading coefficient is negative, so I know that when I'm factoring, I need to have a negative out in front. I have a 6, a 12, and a 3 as my as the coefficients, so my greatest common factor there is 3. I apologize for that noise. So we get a coefficient of greatest common factor of 3 for our coefficient there. Looking at the a's, we have a cubed, a squared, and a, so we're limited to just one copy of the a. I'll open up my parentheses. I'm going to have three terms, again, one for each of these. Negative 6 divided by negative 3 is 2. A cubed divided by a is a squared. 12 divided by negative 3 is negative 4. A squared divided by a is a. And negative 3a divided by negative 3a is positive 1. So one thing you can do if you're unsure if you've made a mistake on any of these, you can check just by redistributing, by simplifying. So to check to see if you made a mistake, you're just going to take this and use the distributive property. So negative 3a times times 2a squared is negative 6a cubed. Negative 3a times negative 4a is positive 12a squared. And negative 3a times 1 is negative 3a. And you can see it should match exactly with where we started right here. And it does. So that's my checking step. But this is my answer over here. Alright, let's look at this one now. You can see for my greatest common factor, there's two terms, first of all. There's that term and that term. So when I'm looking at the factors here, I'm going to look at the 5 and the 3. There's nothing common between them. There's no x on this one, so there's no common x. The greatest common factor between these is just the x minus 2. So I'm going to write that down in front of the parentheses and open up my parentheses and leave room for 2, since there's 2 terms here. Well, 5x times x minus 2 gives us 5x times x minus 2. And for this one, what do I multiply by this to get this term? I need to multiply by 3. So 3 times x minus 2 is going to give us 3 times x minus 2. You'll notice the inside of the parentheses here, we actually have a 5x plus 3. So that's the factored form here. We're getting ready for something called factoring by grouping. We'll see that in the next video.